welcome Mindsetters and welcome to the grade 12s here today. I know it's a very hectic time. You guys are now starting exams, and hectic but very special towards the end of the year. But we're here to help make this, sorry, it's been a long day, help make this a better end to such a successful year. I'm here with Tracy today to do some revision. What are we doing today?
Tara, we're going to be doing prelim review from the chemistry exam, and I'm glad to hear you mumble your words. You know what, I sound like that first thing in the morning before I've had my coffee. and I heard that almost grade 11 moment. Don't worry, I do that all the time. Yeah. My kids go, ma'am, we've been in front of you for 3 terms. Surely by now you know what grade we're in. And I'm like, well, whatever.
I feel a bit guilty because I was the one that was complaining. Don't you call me grade 11. And now
it all happens.
I apologize.
It all happens, and like you said, it's been a long day. It's almost the end of the year, and I know, like you said, it's a very special time, but guys, this is where we put our heads down. Yeah. This is where we fix up our mistakes. And today in particular, we've chosen 3 sections, which when I was marking my learners' prelims, I went, okay, these are the sections that I think are going to be the ones where the most issues will come up, because they're the newest, they're the ones that are got little bits of ifs and buts and things like acids and bases and redox and a nasty equilibrium question.
Okay, so definitely keep your eyes peeled. I know it's end of the day, but we need to work at this. Before we get started, though, I just want to tell you about an awesome competition that we've got going. It's the Get Connected competition, where you can stand a chance to win a Sony Xperia or airtime, which is lovely either way. And it's quite simple to enter. What you must do is that you'll see on our Facebook page, there's a link for you to follow to a Curio page, which will take you to like your favorite teacher presenter. Okay. And what you must do is you like them, and then you come back to the same post on the Facebook page, and you'll see that there's another link next to all the names of the teacher presenters. With that link, you must then also share and get as many likes as you can. The more likes, the better. Better for you and better for your teacher, as those teachers can stand a chance to win a wonderful prize for themselves or their school. And for you, it enters you into the competition to win a phone or airtime. So it sounds great either way, simple and fun, so get onto it. But let's not waste any more time and get straight to the chemistry.
And it's a cool phone.
Oh, definitely.
Oh, it's a very cool phone. I'm needing an upgrade, and I'm like, I might be tempted. Anyway, moving on. Okay, so guys, also, if you look on the Facebook link with the pages, with the notes for today, we do have some multiple choice questions taken from the prelims. So have a look. If we get time, we'll go through some of them. If not, just go through them. They're really important, and they're to do with the sections we chose. All right. Basically, what I'm doing today is I'm looking at the Gauteng Provincial Prelim, and I'm looking at the Eastern Cape Provincial Prelim, because they both had some really, really nice questions in them. And the issue with chemistry grade 12s is, yes, it's the study section of your curriculum. So physics is like very much like maths, where it's learn, and then you practice, and it sums and sums and sums. The nice thing about physics is there's lots of carry down. There isn't in the chemistry, and this is where you lose all your marks, okay? Is that right at the beginning of a section of a section or a question, you make a fundamental error, and we can't carry that down. So it means you lose a lot of marks in the process. So you got to work through these carefully, okay? They're not trying to trick you out, but you have to know your work really, really, really well. Okay, so we're going to look at some papers, and today we're actually going to start off from the Gauteng paper, and this was the equilibrium question. Now, first glance at it, you go, it's okay, it's not so bad, but we're going to work through this quite slowly, because the first part of this question was what would have got you. But the nice thing, actually, is if you didn't get this, and if you look here, the first part of this question was worth 9 marks, okay? Now, guys, read the entire question before you have a whole moment, because I know when you see 9 marks for a question, you sort of go, oh, can't do this. Don't do that, okay? Read through the whole question, and what you'll see is that the rest of this question actually doesn't depend on this answer. So it's okay if you can't do this one. If this freaks you out, leave it, leave space, and go on to the next part of it, okay? So they say to us, when a number of moles of X2, so X stands for any chemical, and Y2 are placed in an empty container, and it's closed, all right? First of all, it's closed, and they tell you that it's 2 decimeters cubed. So this is important. because this is your volume, okay? It's at 800 degrees Celsius, so that's probably also important. Reaction takes place and eventually reaches equilibrium according to the following reaction. So we've got the balanced equation. We're all very happy. We don't actually care what X and Y is, but looking at this is probably based on the Haber process. That's neither here nor there. It doesn't actually matter. At equilibrium, there is 0.4 moles per decimeter cubed of Y2 and XY3. Okay, so I've got two products. You are also given the following information for the reaction. At 400 degrees, the Kc is 0.8. At 600, it's 2.5. At 800, it's 4.0. Guys, they give you those because remember, and this is part of the skill for this question, Kc values are temperature dependent. They're the only things that can change your Kc. If I change pressure, if I change volume, if I change concentration, any of those things, that doesn't affect my Kc at all. Only temperature does, okay? So now they say to you, and this is where they got a bit mean, they say calculate the initial number of moles of X2 and Y2 placed in the container. Your first thought here is we've got a situation where I know what happens at equilibrium, and I know they want something that happens initially. This is going to be the table. Now, grade 12s, some of you might have been taught another method, which would be surprising and probably more difficult, but I'm going to show you a table. I do it as what is known as a rice table. Some of your parents,
well, you never know.
Okay. I know, I think of my kids as my biological
we
children
go.
sometime, and, yeah, let's not go there. But some of your, they call me mom. She's scary. Some of your teachers might have taught you another way. Some of your teachers will also say this is an ice table. It doesn't matter, okay? These are just ways to make it easier for you. But the point is I know I'm going to need a table, okay? So what we're going to do is I'm actually going to draw up the table, okay? So that's the first step we're going to do. Is we always, with an equilibrium Kc calculation, let's draw up the table and see what we know, okay? So remember, our table's going to have enough columns for our products and our reactants, okay? Now, what I do, and my matrics last year called this the fearless line, it's quite funny, but it's just something I do, is I like to draw a double line between the products and the reactants, just because it's easier to remember where my reaction changes from reactants to products. Okay, that's just so that you remember, because on one side you're going to add things to it, and on the other side you're going to take away. So now the first line is the ratio. Now some of you might not have been told to put the ratio here. You do it in the top column, it doesn't matter. Okay, it's up to you. I prefer it there. And our table is generally done in moles, okay? So that's what we're going to do. Over here, this is where the I comes from. So this is initial, and this is going to be in moles. Remember, you still got to have units, even though it's in a table. Then we have our change line, which is where the C comes from. That's also going to be in moles. Then we're going to have our equilibrium line. Okay, in fact, we have to have two here, because at this point, so this is where it reaches equilibrium, so we have to have it in moles. But remember, your Kc value can only be worked in concentration. So this is equilibrium. And this has to be in concentration, so that's moles per decimeter cubed. Okay, so now, they say to us, let's just look at the information I know to begin with. First of all, it's in a 2 decimeter cubed container at 800 degrees, so that means my Kc value is 4, brilliant. And at equilibrium, there's 0.4 moles of Y2 and X3, okay? XY3, so that's 0.4. And now some of you are going, how does that help us, Tracy? We've got pretty much nothing, but we're not done yet. First of all, let's write in the ratio. So from the equation, I know that these go together as a 1, 3, and 2. So this is 1, 3, and 2. Straight away, I know that I have 0 moles of XY3 when I start off with, okay? That is non-negotiable because that has to do with the fact that that is a product, okay? Now, going backwards, let's just see how far we can go before we have to deal with anything else. Remember, concentration is number of moles over volume. So to get number of moles, in other words, to go from equilibrium in moles per decimeter cubed to moles, I now have to take my concentration and times by volume. So I'm going to times by 2. So this gives me 0.8. This gives me 0.8. Okay, so from there to there, I'm going to times by 2 because that's my 2 decimeters cubed. Okay, so we're okay so far. Great. I can't do anything with x because I don't know anything else. Now we look at the change and we go, okay, so when I look at the change, remember, and this is why I draw my little line, we use up reactants and we make products, okay? So to go from 0 to 0.8, I'm going to have to add 0.8. And here's the trick now, grade 12s. This line, your ratio line, and your change line must be the same ratio. Okay? So the 1 to 2 ratio is easy. This is 1 to 2. So for every one x2, for every one molecule of x2, I have 2 xy3s. Okay? Which means I have twice as much. So this becomes 0.4. Okay? I haven't lost any of you, I hope. The next one becomes a little more difficult because it's a 3 to 2 ratio. So now watch here, and this is where I get creative and you have to use your imagination a little bit, okay? Because to get this value over here, I'm going to take my 0.8, I'm going to times it by 3, and if you look carefully between my line that goes down and the blue one I did across, that looks like a multiplication sign, so just go with it. And then I'm going to divide by 2, see? So that becomes my division sign. So I'm going to times by 3, divide by 2, and that gives me 1,2. So now we say, fine, if I started, okay, so now we're doing fine over here, because if I started, if my change was 1,2 and I ended with 0.8, that means I probably started with 2 moles of Y2, okay, because 2 minus 1,2 is gives me 0.8. Hey, we're doing fine, except there's a big blank hole in here. So now we go, okay. Now we say to ourselves, now what do we do? This is where your Kc value is important. Okay, can you see I haven't even used my Kc value yet? Okay, so now I go back here and I'm going to say, fine. What I know is that my Kc is the concentration of my products divided by the concentration of my reactants. Guys, you cannot, some of you might have learned this. Okay, this is not an equation, grade 12s. This is a memory guide. It's a way for you to remember what you put. This will get you no marks. Okay, they will give you naught because it is not an equation. What the equation is the concentration of my reactants, and remember, it gets squared because it's 2xy3 divided by the concentration of my products, and it's y3 squared. Because now watch what's going to happen. Tara, whatever you have, it's...
yeah, I'm spreading it. I've spread it to you.
Apparently. Anyway, it's all right. So now we think about what we know. And remember, this was at 800 degrees Celsius. So my Kc value is 4. All right. So let's make sure you can see it. So that's 4. We knew that this was 0.4, and it's going to be all squared. This is x2, and this one is 0.4 cubed. Guys, they chose these numbers deliberately, because now watch what happens, because I know mathematically you're looking at this and going, yeah, right, whatever, Tracy, have a nice life. It's all right, don't stress about it, because now I want x2, the concentration on its own. So that means I'm going to have to take the 4 over, the x2 and the 4 change places. And I'm hoping some of you are actually seeing a way, looking at this from exponents and stuff, going, well, actually I can make this quite easy on my calculator if I needed to, but just in case, it doesn't matter, let's put it into our calculators. And remember a little while ago I told you I'd actually learned how to use the X button. I really have learned again. I've learned since then. I've looked at it again, so 0.4, no. Helps if I put all the numbers in. There we go. So 0.4 squared okay, which is going to be divided by 4 times 0.4. Now, the nice thing about these calculators is you've got a cube button, so it makes it easier. We're going to close our brackets. We're going to get to the end of the fraction, and we get 5 over 8. Remember, we can't leave it as a fraction, so we change it. Gives you 0.625. Guys, use the whole. Don't round this off, please. Okay, so that means x2 is 0.625, and that's moles per decimeter cubed. So now I'm going to go back to my table. That's 0.625. Remember, that was moles per decimeter cubed. So now I'm going to times by 2. That gives me 1.25. Okay, in case you don't believe me, watch. Ooh, no, that's not the one I wanted. Let's go there. There we go. So I'm going to take that answer times by 2. Okay, 1.25. Now here, I took 0.4 away from my original, and it gave me 1.25. So that means my original is 1.65. I'm about to write all sorts of other funny numbers here. So let's write down the proper answer. 1.65. Okay, this is a mean equilibrium. Okay, this question, 9 marks, and that's taken us more than 10 minutes. That's fine. Please don't look at your watch and go, it's taking me 10 minutes. It's fine. You've got plenty of time, all right? Work through it. This is about as mean as they can get. I actually have never seen one like this. They finally gave something new, which was like, wow. But it's very cool. So there's more to this question, guys, but I think it's time for a break, and then we'll finish off the rest of this question afterwards.
Sure. Wonderful. So now you've been exposed to a more tough kind of question, but it's lovely to get to see that. Just before we go to the break, I need to keep you for 1 minute longer just to tell you about an awesome competition that's also running. A lot of you are in the process of getting your learner's license. It's been a hectic year, so it's understandable to get it now towards the end when things start calming down a bit. And a wonderful book I would suggest to get is the Safeways K53, this wonderful one here. You can also download the app from the Samsung Galaxy App Store or the Google Play Store. And downloading it or buying it with the receipt that you receive, you can enter a competition which can allow you to win a Chevy Spark, which is absolutely incredible. It's a win-win situation. While you're beginning to prepare for your learner's license, you also stand a chance to win a car. So I won't keep you too long. Just to let you know that this is going, you can check all the details on Facebook, and we'll see you straight after the break. Welcome back, Matrix. We've got so much to do. I've got a couple of questions, though, which I'll get to straight away. But before we do that, as you've seen, I've posted the links to the notes that for today, this evening more so. And you can download them or just view them. But at the bottom, you'll see that there's a test yourself, which is really important. I feel like we can cover this, but it's important to know where you stand with your understanding. So go through it, test yourself, and see where you are, see what you do and don't know. You will get some instant feedback, which is fantastic. But doing that also enters you into another competition to win a Casio calculator, which is wonderful. But that's it for now. There's 2 questions on KC, which I feel are quite valid and important to get through.
Okay.
So the first one here is from Wamhundi.
Okay, both of us are going to butcher your names today, guys. I'm sorry.
No disrespect.
Sorry.
We're just horrible.
Yeah.
It says, hi, I'm lost on the KC calculation on how it got into 0.4.
Okay, the 0.4 was given in the actual question, sweetie. So if we look at it says right at the beginning, and this is why, and I'm sure you saw as I was reading it, you saw that I circled some stuff, underlined some stuff. You need to do that while you're reading your question, because then you don't lose track of information. So at equilibrium, there is 0.4 moles per decimeter cubed of Y2 and XY3. Okay, so it was given to me in the question, which is why I could then write it in purple. Okay, and with all the many colors on the board, everything I wrote in like the pinky purple color, that was, well, first of all, that's my setup, but that was given to me in the question. So that's where I got the 0.4 from.
Yeah. Important. I feel like using colors can also keep track of all of that. So
Yeah.
maybe do that if you
Yeah.
have the time. The second one was, why is Kc value not affected by concentration and pressure?
It's one of those strange things. It's a hard one to explain, but yeah, they're never actually going to ask you that. But it's more because Kc value is a ratio issue, okay? And when it comes to your temperature, it affects the energy and rates and all sorts of things, which is why it affects your Kc value. Whereas with concentration and pressure and all of those, the system then resolves itself back to having the same ratio of everything, because the overall energy of the system has stayed the same because the temperature is constant. It's a strange thing, I know. Even now, and I've been teaching for a long time, I sort of go, yeah, it's a hard one to get your head around.
Yeah.
But unfortunately, it's one of those things where it's got to do with energy changes and states and enthalpy, but you don't need to know any of that. You just need to know that it's only temperature that can change it.
Okay, so that was from Eldridge. I was the same. I always had to understand why, but sometimes it's better to just.
And there's some things that are just so beyond your curriculum that, it's unfortunate because there's so many things we'd love to delve more into, but we just don't have the time, unfortunately. Okay, so I hope that sort of helps for now, but just hang in there. Okay, all right. And if you are going to be doing science at varsity, you'll learn why. Okay. That's just such a lame answer. Anyway, moving on. All right. So now they give us the same question. It's still part of the same thing. Now they ask us, is the forward reaction endothermic or exothermic? And then they ask you to explain. So now we've got to look at the Kc value. So now we look over here. Okay. And as my temperature is increasing, the Kc value is getting smaller. Now remember, Kc is concentration of products over concentration of reactants. So if my Kc value is getting bigger as my temperature gets higher, I apologize. That means if this value is getting bigger, then the amount of product I'm getting is getting bigger as well, because my top part of my system, this part must be getting bigger while this one's getting smaller. Otherwise, I wouldn't get a bigger answer, okay? That's a pure maths algebra issue, okay? So if I'm getting more product, watch, I'm increasing the temperature, which is leading to more product. So increasing the temperature is favoring the forward reaction, okay? And what you should remember is whenever we increase temperature, it favors the endothermic reaction. So that means my forward reaction is endothermic. Okay? Because equilibrium, I like to call it, is a little bit like a teenage girl. So Tara's not quite, she's still almost not really. Pretend. Sorry, I apologize, but she's never happy. Okay? She can never make up her mind. When she's hot, she wants to be cold. When she's cold, she wants to be hot.
Never satisfied.
You know, it's that whole thing of when she's got a boyfriend, she doesn't want a boyfriend. When she likes a boy, and then he likes her, she doesn't like him anymore. It's one of those things, okay? It's just never happy. Same thing. So when I increase the temperature, it now wants to decrease the temperature, okay? Which is why it favors the endothermic reaction, which makes it colder. So by increasing the temperature, I'm favoring making products. Let's just put product here so you don't get confused, which then means I'm favoring the forward reaction, so the forward reaction must be endothermic. Okay. So it says, explain your answer. Guys, best thing I can tell you, particularly if you have a horrible handwriting, okay, and you get all worked up and you know, your handwriting becomes difficult and you've been moaned at all your school life that your teachers can't read your handwriting. Guys, write your answers in point form. This is not history or geography or English or any of those subjects. We don't want essays, okay? And I speak for a lot of science teachers out there. We became science teachers because we didn't want to mark essays, okay? Because we're not very good with our languages. So, guys, write your answer in point form, but it must be in logical point form. So don't skip to the end and go, favors the forward reaction, therefore, okay? Therefore favors the forward reaction is the final part, okay? So this is what we write. We increase the temperature, okay? increased temperature, okay, meant that the Kc value increased, sorry. Kc value increased, okay? And you're going to have to write a lot for these 2 marks, okay? Your Kc value increased. This means, so therefore, forward reaction was favored. And I'm pretty sure none of you can read what I just wrote, but go with it as reaction favored. That means forward reaction endothermic. Okay. Same thing we wrote. Now it says, now be careful with the question. It says, what effect will adding more Y2 have at 800 degrees, so Kc stays the same, have on the following? First of all, on the rate of the reaction. Well, if I put more stuff into the reaction, there's more particles. If there's more particles, then there's more chances of effective collisions. So that means it's going to increase the rate of reaction. Okay, no explanation needed. Don't put the explanations. Another place where you tend to lose a lot of marks is some of you need to think through. So just what I was saying to you, that's how you guys work through your answers. And for a lot of you, you write that down. Nothing wrong with it. I encourage you to write it down, but don't write it down in your answer book. Write it on your question paper, okay? Write down your thinking on your question paper or at the back on the last page of your answer book and then cross it out at the end, okay? Or, and this is harder to remember, cross out all your thinking when you're done so that we only get the answer. Because remember, your markers aren't going to sit and read. It's a 1-mark question, okay? And it says, answer only, increase, decrease, or stay the same. We don't want to see the explanation. And sometimes you contradict yourself in your explanation and then you lose your marks anyway, okay? So be careful. Just write down what we want. Now they want the concentration of X2. So remember, by putting more Y2 in the reaction, it's going to want to use it up. So we're going to favor the forward reaction. The forward reaction is going to be favored, which means we get more XY3, but that also means that we'll end up using the X2. So that means the X2 decreases. Okay, decrease. And another thing, your teachers would probably kill me for saying this to you, but I say this to my own learners. If you don't have a clue, choose one of those 3. Seriously. If you choose one of those 3 as your answer, you have a 1 in 3 chance of getting it right. Put nothing down, 100% chance of getting it wrong. It's like multiple choice. Make a choice. Okay, we've given you, it's almost like a multiple choice question. Shh, I didn't say that. Okay, try and make an informed choice, but write something down. There's no reason for there to be a blank at this point. Okay, now, next part. Now they say, which one of the following gases, XY3 or X2, would be present in a higher concentration in the equilibrium mixture at 400 degrees? Now, if we go look over here, remember, at 400 degrees, my Kc value is much smaller. Okay, and it's significantly, it's not just half, it is a huge amount smaller, which means that now I have far less product and lots and lots and lots of reactant. Okay, so the value at the bottom of my fraction is much bigger than the value above my fraction. Okay, and the value above my fraction comes from the reactants, which is X2 and Y2. So that also tells me that I have more X2 than I didn't write that. See, that's what you can do in your exam too. X2 then XY3. Okay? Now they ask you to explain your answer. It's exactly what I just said. Okay? So at the 400 degrees, Kc is 0.8. Okay? So it's much lower much, see, this is what you do in your exams, so it's much lower than at 800 degrees. Therefore, there's more reactant present. Okay, reactant, let's go all the way down. Okay, so at 400 degrees, the Kc value is 0.8, which is much lower than at 800 degrees. Therefore, there is more reactant present at 400 degrees. Okay, so guys, it's all about you working through your question. A lot of this was based on your Kc value, but the last, let's see how many marks this was 2, there was 2, 3, 4, 5, 7, 8 marks. So this question was out of 17. The last 8 marks were completely doable, even if you couldn't get 1.1, okay? But even in 1.1, if you'd worked through it the way I told you to do, you would have got some marks, okay? You wouldn't necessarily have got full marks, but you would have got something, okay? But none of these answers is dependent on that 9-mark question. Do not get upset about seeing 9 marks at the beginning of a question, okay? Are there any more questions on this at the moment, Tara?
I think
just
I
to put you on the
actually
spot,
no.
otherwise I'm going to go on to the acid and bases.
So it's fine. Okay, so the one question here was, the rate of both forward and reverse reactions increase.
Okay, which was for, the rates of the reverse, okay, yes, okay, I know where this came from.
Yes.
All right. This actually came up when we were marking this. We had a bit of a debate in my own department about this, because we go, okay, it favors the forward reaction. So the reason why your reverse reaction increases, okay, is because as I'm making more, so I add more Y2 into it, that makes more XY3. So as soon as I've got more product, that means that reaction also increases, which is why the reverse reaction also increases. It's you want to say it decreases, because you go, well, the forward reaction absolutely increases, because the forward reaction will increase for a little bit, but then the reverse reaction increases to make up for it. Yeah. Okay.
Okay.
That's it. Yeah, it is right, I promise. Yeah.
I don't know if I'll have time for this, but let me just...
Yeah.
So the
That's
question
okay.
was, if you could work out the Kc in reverse, where we're given the equilibrium constant, and we're required to work backwards.
That's what we were doing in the first question.
Okay, so then it's been covered.
That's what we gave. They gave us the
Okay.
constant and we worked backwards. That was the first question. Yeah.
Okay, then those are the questions
Brilliant. Okay. Moving on to acids and bases. I actually also like this question. I'm so mean. That's why my kids don't like me setting tests. They prefer everyone else. All right, so you are given the following ionization reaction of ethanoic acid in water. We're great. Okay, so it ionizes. What does the ionization constant indicate? It should say indicate, not indication. Does the ionization constant indicate about the strength of the acid? Guys, this is a tiny constant. Tiny constant. It's 10 to the minus 5. This means it's 0.000. I'll write it out for you. 0, 1, 2, 3, 4. That's the value. It is ridiculous tiny. That means that this is a very weak acid, because by having a very small ionization constant, it means that it only ionizes a little bit. That makes it a weak acid. Okay, definitions. Different to what is meant by a concentrated acid, guys. Definition time. Concentrated acid, I'm not going to write because I'm worried about time. Concentrated acid means that I have a large number of acid particles per volume. Okay, not dissolved particles, large number of particles per volume. Okay, now, I love this one. H2PO4 is an amphiolite. Now we start using, as I say to my kids, H2PO4 minus is confused. Okay, it doesn't know if it's an acid or or a base. Remember, an amphiolite will act as an acid in the presence of a base and will act as a base in the presence of an acid, because sometimes it wants to take hydrogen, sometimes it wants to give hydrogens away.
It's like a teenage girl again.
Pretty much. There's a lot of teenage girls in chemistry, or just teenagers in general.
Oh, well, yeah.
It all depends. Every now and then we call them teenage boys, but boys get upset when they get told they can't make up their mind. So teenage boys' egos are more fragile.
Okay.
Particularly if they're rugby players. Yes, we always pick on my rugby players because I can. Okay, so H2PO4 minus is an amphiolite, writes an equation to indicate its role as a base. Remember, as a base, it must accept a hydrogen. So this is what they wanted, okay? The H3PO4 minus. Guys, do this as simply as possible. Don't get all technical here, okay? Use water with it. Okay, if it's going to act as a base, it is going to take the hydrogen away from the water. It is going to turn back into an acid, which is H3PO4, and we're going to have OH minus, because the hydrogen is going to give away the water is going to give away its hydrogen to the H3PO4 minus. It's going to take a hydrogen. That makes it a base. Please be careful with these, okay? I saw all sorts of weird and wonderful things. I saw people put H plus in there and use water. Easiest one to do. Okay, now, I think, Tara, let's take another break, and then we will finish off this question.
Sure.
Yeah.
There is an awesome event happening this weekend that I want to tell you about just before your break. It's hosted by Shell, and it's going to be at the Kailami racetrack, and it's the Shell Eco Marathon. And it's challenging students all over the country to kind of come up with ideas. So design, build, and test your own fuel-efficient vehicles, which is absolutely incredible, because we're here offering you opportunities to win cars, and there's some of you out there that possibly have ideas to make fuel-efficient cars. So I think it would be an incredible event to go to. Entrance is free, and it's at the Kailami racetrack on Saturday and Sunday of this week, the 25th and the 26th of October. So definitely we hope to see you there. We'll see you after the break. Welcome back, Matrix, for our last little session here today with Tracy. Now, we're going to be doing a little bit more revision with you guys in preparation for your exams next weekend, and we're going to be going in sequence of what exams are coming up to help you out a bit, just to make sure we cover up last-minute things. It's always important, but not to stress you out. So we'll be starting with the live show covering accounting at 3:30 on Monday, so there will be revision and throughout the whole of that week. But seeing as the accounting exam is on Wednesday, we want to see we cover as much as we can for you guys then. So please tune in, and we hope that we can help you and prepare for this time.
Yeah. All day before the live show will be just accounting.
Yes,
the way we understand it. So we're not going to make you study, do all sorts of things. So it's going to be focused on, so you're pretty much not going to see any science for a while, because science only not next week Friday, it's 2 weeks Friday, and then 2 weeks Monday or something. It's okay, we're fun, we can manage. Shame the art students are busy with their 24-hour art prac this year. 24 hours.
Oy.
They're having to sit at school for 5 days for 5 hours at a time. It's ridiculous. Anyway, moving on. There's the reason why I didn't teach art either. Anyway, so now they say to you, write down a conjugate acid-base pair from your equation in question 2.3. Guys, they didn't want both pairs, where there's always two. And remember, so this is now acting as a base, which means it's going to turn into an acid. That's its conjugate acid. So I could have written down H3PO4 minus and that should be H2. I've written that wrong, and maybe somebody picked it up and they've just been nice and haven't said anything. That should say H2PO4 Wow. Okay, H2, PO4.
Yeah, somebody picked it
Did
up.
yeah, thank you. At least you know it really is live, okay? And H3, PO4. Or you could have written your other one is actually the water, which acted as an acid and became a base. Okay, either one, they only wanted a conjugate acid-base pair, only one, it's only worth 1 mark. Okay, which means it's all or nothing, only write 1. Okay, now, the next part of this question is quite nice. Milk of magnesia has been used over the ages to relieve stomach ailments caused by excess acid. In other words, it is a very good antacid. Okay, it's the main ingredients in our antacids, and we know there's often lots of adverts for them on TV. Okay, we won't name any because there's always issues. Okay, the active ingredient in milk of magnesia is magnesium hydroxide, MgOH2. A group of learners prepare a solution of magnesium hydroxide. Great. Look here, what mass of magnesium hydroxide must be dissolved? So they want mass to prepare 500 centimeters cubed with a concentration of 0.2 moles per decimeter cubed. Guys, over and over and over again, I'm going to have to tell you this. Stoichiometry from grade 11 is extremely, extremely, extremely important, okay? They are going to ask it. Unlike in grade 11 where it was specifically a question, okay? So it was specifically, you knew they were asking you chemical reactions or chemical calculations. This is going to be asked in equilibrium, in rates, acids and bases, redox, in your electrochemical cells. Absolutely, it can be asked anywhere, so make sure you know it. Now they wanted what mass must be dissolved. So you've got a couple of equations, one of which, and the easiest to use is this one. Concentration, molar mass over volume. We want little m, but we don't have big M. We don't have molar mass, okay? So this is where we go, and I would actually work it out separately. And we're going to write it out here. And I don't know the mass of magnesium off the top of my head, so I'm going to go to my periodic table, and we go and we look it up, and it is 24. We love our periodic table. It is our best friend in chemistry. Okay, so treat it well. So it's 24, and oxygen is 16, hydrogen is 1, and there's 2 of them. So it's 24 plus 37, no, 24 plus 17 times 2. 17 times 2 is 34, and I shouldn't really try to do this in my head. It's never a good idea, but it gives us 58. Okay, grams per mole. You can always double check that if you need to for me, okay? So it gives us 58. My concentration, 0.2. We want little m. My mass, molar mass is 58. The volume is 500 centimeters cubed, which makes it 0.5 decimeters cubed. Make sure you've got all the right conversions. So here, it's going to be 0.2 times the 58 times the 0.5, which gives me 5.8 grams, okay? Nice and small, what we expect, okay? If you got a big number there, I would be worried because it's a fairly small volume, 500 centimeters cubed, that's half a liter, and it's 0.2 moles, that's fairly dilute, okay? So if you got a very big value here, I'd be worried. All right, now they say, what will the concentration of the hydroxide ions in the solution be? Assume 100% dissociation. Guys, if you can't see it from the equation, okay, now I need you to see this. MgOH2. Okay, guys, for every 1 mole of magnesium hydroxide, I have 2 OHs in that molecule because it's OH2. Okay, if I have to break this up into its ions, so if it has full dissociation, so we add it to water, and this is just to show you, I would get Mg2 plus 2 OH minus. Okay, so when we write this in, and this is what we'd expect, the concentration of the OH minus ions is going to be equal to twice the concentration of the MgOH2, okay, which means it's going to be 2 times the 0.2 And so that gives me 0.4 moles per decimeter cubed. Okay? So we're all fine with that. 2 marks, easy enough. The nice thing here, though, is because that was a calculation, if you got that one wrong, we brought it down to this one, so it makes it easier for you. But now life gets interesting, because now it says, the pH of any medicine safe for human consumption must lie between pH equal to 4 and pH equal to 9. Something I didn't know, but it's good to know these things. Will the solution that the learners prepare be safe for human consumption? Now, this is actually an important question, because how many times do you think, well, you know, milk, magnesia, MgOH, it's what we use for antacid, we put a solution together, oh, can't really hurt me. Of course it can, okay, because we don't know. Even though we use it for human consumption, we need to check, because there's other stuff that we do in the process. So what we need to work out is the pH. And remember, from our information sheet, pH is the negative log of the H3O plus concentration. So now you're saying, but Tracy, we don't have the H3O plus concentration. No, we don't. But we do know. Okay, now this is my thinking. I want you to see how we work this out. We do know that the OH minus concentration is 0.4. Now, they gave you a bit of a hint to this question right at the beginning, because they started to speak about the ionization constant of an acid. Whenever we're dealing with pH, we're now dealing with the ionization constant for water. Okay, and remember that for water, the ionization constant, it's H3O plus times OH minus, which must give me 1 times 10 to the minus 14. So if I know the OH minus concentration, which is 0.4, I can work out the H3O plus. So now if I put it into my calculation like this, okay, this is 0.4. It's 1 times 10 to the minus 14. This was worth 5 marks. I'm probably going to have to do 2 equations, so I'm not worried at this point. So let's take my calculator out. Ooh, stop it. There we go. So we're going to go 1 times 10 to the minus 14 divided by 0.4, and we get 2.5 times 10 to the minus 14, and we're expecting it to be small. Okay, let me just double check that. Yep. Okay. I'm expecting it to be small. This is a base. Okay, as a base, it has a very small H3O plus concentration, because the H3O plus is what makes it an acid, okay? So now we can go back here and we can say, well, pH is the negative log of the H3O plus concentration. And I'm quite grateful that they did this, because remember, for those of you who do maths literacy, you've never actually done this calculation in maths literacy. It doesn't matter, okay, because this becomes straightforward substitution in your calculator, okay? So it doesn't matter that you haven't done log scales, that you don't really understand what they mean. It's irrelevant, okay? And I know it's not nice to do something where you don't really understand the maths behind it, but fortunately there's not much we can do about that. So you go minus and log. We can open our brackets, and this is 2.5 to the minus 14. Close our brackets, and we get 13.6. Okay, but we're not done. First, because that wasn't the question. The question was, is this safe? Will this solution be safe for human consumption? Show all your calculations. I got 13.6. Not a chance. No, it isn't safe. Okay, answer the question. That is worth 1 mark. 1 mark. I see it all the time. You get so excited, you got to the pH, and then you forget to answer the question. And then we go, okay, that's nice. You'd get some marks, but 13.6. Way, way not safe. Okay, that's almost 14. pH can go higher than that. That is going to do some serious damage. Okay, it won't necessarily kill you, but that's not pretty at all. Okay, so, now, we're not done yet. One little quick question. We'll see if we get there. And I'm not sure I'm going to be able to get through all of it, but I'll try. The learners now check the concentration of the solution they made. They run a titration using hydrochloric acid of 0.1 moles. They transfer 25 centimeters cubed of the magnesium hydroxide solution into a conical flask. The balanced reaction is, yay, they gave it to us balanced. Determine what volume of HCl is needed to fully neutralize if the concentration was 0.2. So let's just realize that for this one, this is the equation I'm going to use. Okay. Volume of acid, concentration of base, volume of base, and the big thing here, that ratio comes from here, where the 2 is for the acid, the base is 1. So that's 2/1. Now our issue becomes, where do we get all our values from, okay? Because now they've given us a whole bunch of stuff. So now we go, okay, they actually don't tell you how much hydrochloric acid they used. They used 0.1 moles. They used 25 centimeters cubed of our original. So this is 0.1. That's my value. My volume, that's 0.2. They told me I used 25 centimeters cubed. You don't really need to change it. Okay, so my acid, and we're going to show you, oops, sorry, becomes 2 times 0.2 times 25 divided by 0.1, and that gives me 100. Okay, let me just double check for you though. 2 times 0.2 times 25, because you never know with my maths, divided by 0.1 gives me 100 centimeters cubed. Okay, guys, you may or may not have done this particular equation in grade 11. You are absolutely welcome to do it the old-fashioned, well, not old-fashioned, the long way, with 1/got and mole ratios and that sort of thing. Up to you. This equation, however, much easier. There is a third question on the notes that are available to you guys. Please go and do it. It's a really nice redox question. Okay, the memos will be made available to you guys, so make sure you go do it. I'm sorry I didn't get there, but I think I'm going to have to say goodbye. Guys, study hard. I will be here for the live shows in a couple of weeks just before your physics and your chemistry paper, okay? And vote for me.
Thank you so much, Tracy. I always enjoy listening to you. I learn something new every day, and I hope that you guys did too. Granted, it shouldn't be new now, but for me it is. It's kind of old now. So there's a lot of competitions going on at the moment. Make sure that you see what's happening, enter. You could win some awesome competitions. Don't forget about the really cool event happening this weekend. I think it's going to be absolutely incredible to see what you guys can come up with. Thank you so much for joining us again today, and we'll see you soon, Matrix. Good luck.